We are on slide 7 of Unit 9. We are continuing to talk about quadratic functions. So let's look at this first one. So it's graphed. We need to identify the axis of symmetry and draw the line. Oop, we have a line here. So the axis of symmetry cuts it in half, so you can see it on there. So our axis of symmetry, the line is x equals -1. The y-intercept, I wonder if it lets you do that. Oh no, we don't want to do that. The y-intercept is right there. So we need to write it as a coordinate. So that would be 1, 2, 3, 0, 3. I don't know why this is so big. I think I can make it a little smaller. So it's just over that. And then our vertex is the either lowest or highest point. So it's right here. Let's see. So that's at -1, 2. The domain is all possible x values. So with quadratic functions, it's always all real numbers. So we are going to write it as -infinity because we want to write it as an inequality because that's part of the teak or the skill is writing it as an inequality. So insert special character. And I'm going to copy and paste this a couple times. -infinity is less than x is less than infinity. Then our range is our y values. The lowest y value is right here, but it can equal it. So it's at, what is that, 2 to infinity? Or we can say y is greater than equal to, is there a way to do greater than equal to? Underline it. That's what y'all said. There we go. Okay, that works. Greater than or equal to 2. Then number of roots, 0 solutions. How many do we have? So roots, 0 solutions. What does that actually represent? What are we looking for on our graph? When we are asked for roots, solutions, or zeros. Y'all can tell me. What are we looking for?
X.
X what?
X.
Like
Intercept.
Intercept, yeah. Where does it cross the x-axis? Do we have one on this?
No.
So we would put none. Then do we have a maximum or minimum? Minimum. We have a lowest point. Yep. Minimum. Okay, so with your table, I'm going to have you fill out the other 3 of these right now. Okay, you should be done with them now. So we are going to go over each graph. So bottom left, the axis of symmetry is x equals -2. Y-intercept, 0, -4, which would be right here. Vertex, -2. Oh, I don't have it. Sorry, it's frozen up there. Okay. -2, 0. So far, y'all agreeing with me? Okay. Domain on this one, -infinity to +infinity. And the range, y is less than or equal to 0. We have one root, 0, or solution, x-intercept, and our vertex is a maximum point. Okay, top right. Our axis of symmetry is at x equals 1. Our y-intercept is at 0, 8, right here. Our vertex is at 1, 9, right here. So now we need to talk about our domain. So our domain is our x values. This one is restricted. It doesn't go beyond our x-axis. It doesn't go below that. So it's going from -2 to +4. Those are the only values of x. So x is between -2 and +4. I just write it like that at first, and then I fill in my inequality. They're always less than if you go from least to greatest. So on this one, it's an open circle, so -2 is not included. So it's just a less than symbol. So -2 is less than x. And then the symbol between x and 4 is included. So it's a less than equal to symbol. So -2 is less than x, is less than or equal to 4. Now the range goes all the way up to 9 and all the way down to 0 because you're looking at your y-axis. How high does it go? How low does it go? So it starts at 0 and it goes to 9. So y is between 0 and 9. Is it equal to 0? Yes, because even though this one's open, this one's closed. So 0 is a solution. So that's less than or equal to. And then the 9, it goes all the way up to 9 on the y-axis. So it's also less than equal to. So 0 is less than or equal to y is less than or equal to 9. Okay, let's look at our last one. Axis of symmetry is at x equals 2. The y-intercept, 0, 0. And the vertex is at 2, -4. Then our domain, because of the arrows, it goes on and on forever. So -infinity to +infinity. So -infinity is less than x is less than infinity. And then our range, our lowest y value is -4, and it is greater than or equal to -4. So y is greater than or equal to -4. Oops.
But Mrs. Saucy, on the third one, how is there only one root?
Oh, I didn't go over that part. Because is this one actually included? Nope. It's not actually included because of that open circle. That's why it's only one root. Great question. Game changer, I know.
Wait, Mrs. Saucy, what was the range for number 4?
The range was y is greater than or equal to -4. And on this one, we have two roots, two locations that crosses the x-axis, and we have a minimum value, a lowest value. Any other questions? Those were good questions. Okay, so this is looking at a graph and identifying the different characteristics on your EOC. A lot of the questions are like that. We also need to know how to graph it. So we're going to look at slide 8 now. So slide 8 is, let's say you're given a quadratic function and then you're asked for the different parts of it. So you actually have to graph it. We're going to use our calculator a lot on this. So if you don't have your calculator out, you need to get it out now. Okay, so here are the steps for graphing quadratics. We're going to use our calculator a lot on this, but I want you to know how to find your axis of symmetry because sometimes it is not directly through a whole number. Maybe it's a decimal. So remember back over here, we have this. Y equals, this is on slide 6, y equals ax squared plus bx plus c. If you don't have that, you need to have that on slide 6. And also copy it and paste it over on slide 8. So that we can refer back to this. And get out your composition book because I want us to look at writing our axis of symmetry. So I went ahead and wrote this in my journal, graphing quadratics. I'm going to write that y equals ax squared plus bx plus c. This is called our standard form of the quadratic. And this is in our formula chart. So see how all 4 of these formulas are on our formula chart? They give us standard form. That's the one that we're going to talk about today. We're not going to worry about the next 2 right now, but we're going to talk about axis of symmetry. It's also on here. So let's go ahead and write that axis of symmetry. And a lot of times I'll write as AOS. And it's x equals negative b over 2a. So we'll look at that first example. We're on slide 8? The equation is y equals x squared plus 3. And if we write this in standard form, it's y equals 1x squared plus, there is no bx, so we put 0x plus 3. So a equals 1, b equals 0, and c equals 3. So we can write our axis of symmetry, AOS, x equals negative b over 2a. I always write the formula first and then I plug in my numbers. So this would be x equals negative 0 over 2 times 1. which just equals 0. So our axis of symmetry is x equals 0. Okay, the next one is our vertex that we're going to find. And in our notes, it says, find the vertex by plugging in the axis of symmetry into the quadratic equation. So that means you're going to plug in a 0, because our axis of symmetry, if x equals 0, y equals question mark. We're plugging in our axis of symmetry. So we have our equation y equals x squared plus 3. So y equals 0 squared plus 3. So what does y equal then? Yeah, y equals 3. So our vertex is at when x is 0, y is 3. Okay, so axis symmetry, vertex. The next one is our y-intercept. Our y-intercept is when you have it on the y-axis, right? So where it crosses the y-axis. So we want to plug in 0 for x and solve for y. So in this case, it's actually the same as our vertex. So we'd say y equals 0 squared plus 3. Just y equals 3. So our y-intercept is at 0, 3. So it's the same in this case because there's no b value. That's what changes it. Which direction is this going to go? How's it going to look? Is it going to go upward or downward? It's going to go up because this is positive, right? So it's going to go up because A is positive. It's going up. So are we going to have a minimum or a maximum? We will have a minimum point. Okay, that is all we're going to do today. We'll finish this slide and one other slide.
Teachers, I'm sorry for this interruption, but when the bell rings, I need the following students to come to the office: Michael Bailey, Brian Van